Okay, so today we're going to learn about separation techniques. So remember we talked about the matter concept map and we had elements and compounds, which you cannot physically separate. You can't physically separate them. You can chemically separate a compound, and an element you can't do anything to. However, on the other side, we had mixtures. What was one type of mixture?
Heterogeneous, or how you say it?
Yes, I heard both. I heard Whitney and yes, homogeneous and heterogeneous mixtures. Okay. So remember, a homogeneous mixture is a solution. And homogeneous mixtures, they look the same throughout. Why do they look the same throughout? What's up with their particles? Why do they look the same
Really
throughout?
small.
Yeah, the particles are super small. They're so small that it looks like you're looking at one thing, even though there may be different stuff mixed in there. Okay. So today we're going to talk about how do I separate mixtures. So it doesn't matter if it's homogeneous or heterogeneous, we can separate them physically. Now, if you think about it, it's probably a lot easier to separate the peanuts out of a trail mix than it is salt from water, okay? So there's different techniques depending on the properties of those mixtures. So I'm gonna start with a video, it's like 4 minutes. It's called a TED Talk. I love TED Talks. They're like great videos. They're short, well, they're not always short. This one's short. It's just going to give you a little overview of different separation techniques and how we use them all the time, even when we don't think about it, all in all industries, in science, in industry, in food, everything, medical field, everything. So short 4 minute video, and then we're going to go through a couple different ones, and I'm going to tell you what you need to know about those separation techniques for the test. Okay, so let's start with the video first. Okay, let me find my video. And then, okay, let me pull this up. And we'll watch this short video and then we'll go from there. How do we separate the seemingly inseparable? All right. Am I sharing? Good. Here we go.
Your cell phone is mainly made of plastics and metals. It's easy to appreciate the inventive process by which those elements are made to add up to something so useful and entertaining. But there's another story we don't hear about as much. How did we get our raw ingredients in the first place from the chaotic tangle of materials that is nature? The answer is a group of clever hacks known as separation techniques. They work by taking advantage of the fundamental properties of things to disentangle them from each other. Simple separation techniques apply to many physical scenarios, like separating cream from milk, extracting water from soil, or even sifting out flecks of gold from river sand. But not all mixtures are so easy to unravel. In some of those cases, we can exploit the differences between physical properties within a mixture, like particle size, density, or boiling point, to extract what's required. Take petroleum, a mixture of different types of hydrocarbons. Some of these are valuable as fuels, and others make good raw materials for generating electric power. To separate them, experts rely on one important feature. Different hydrocarbons boil at different temperatures. During the boiling process, each type vaporizes at a precise point, then gets separately funneled into a container and collected as a liquid as it cools. Separation techniques also take us to the sea. In some drought-stricken countries, the ocean is the only available water source. But of course, humans can't drink salt water. One way to get around this problem is to remove salt from seawater with reverse osmosis, a process that separates water's ingredients by size. A membrane with pores bigger than water particles, but smaller than salt particles, only lets fresh water pass through, transforming what was once undrinkable into a lifesaver. Meanwhile, in the medical world, blood tests are a vital tool for evaluating a person's health. But doctors typically can't examine blood samples until they've separated the solid blood cells from the liquid plasma they're dissolved in. To do that, a powerful rotational force is exerted on the test tube, causing heavier substances with higher density, like blood cells, to move away from the rotational axis. Meanwhile, lighter substances with lower density, like plasma, move to its center. The tube's contents divide clearly, and the blood cells and liquid plasma can be tested independently. But sometimes, unlike oil, seawater, and blood, the parts of mixtures that we want to separate share the same physical properties. In these cases, the only way to isolate ingredients is by chemical separation, a complex process that relies on unique interactions between components within a mixture and another material. One of these methods is chromatography, a tool forensic scientists use to examine crime scenes. They dissolve gathered evidence in a gas and can monitor and analyze the ingredients as they separate and move at varying speeds due to their unique chemical properties. That information then tells scientists precisely what was present at the scene, often helping to identify the culprit. Separation techniques are not just about industry, infrastructure, medicine, and justice. One of the most technically ambitious projects in human history is a separation technique aimed at answering the fundamental question: what is the universe made of? By accelerating particles to extremely high speeds and smashing them into each other, we can break them into their constituent parts, ever so briefly. And if we succeed at that, what's next? Is there a most elementary particle? And if so, what's it made of?
Okay, so tell me, was there anything, and this isn't a trick question, was there anything that stuck out to you, like any separation technique or anything that you saw that was like, oh, okay, that's kind of cool?
The crime scene.
The crime scene, exactly. So chromatography, I think that's pretty cool. I actually thought about doing that when I first went to school, and then I realized I don't like blood, so I changed my mind. But it's kind of cool. They do a lot of stuff where, you know, if you've ever watched, like, I love Criminal Minds. Okay, so like Criminal Minds. Now I'm on this new NCIS New Orleans kick. But Criminal Minds, Law and Order, NCIS, I love all the cop shows, and how they take stuff and they're like, go to the lab and they're mix it in here. And like with chromatography, they were saying they pick up a substance and they dissolve it in something, and they can watch how fast that stuff moves. Things move at different speeds, and they can figure out what it is. So that's kind of cool. Did anything else stick out to anybody else? It's okay if it didn't. I thought we're going to talk about centrifuging. I think that's pretty cool. They talked about how, because like usually when you look at your blood, I'm like, it's blood, but blood actually has a lot of stuff in it. And so when you do a centrifuge, which is basically this machine that spins it really, really fast, it will actually separate the blood out. And I've spent all day trying to find a really good centrifuge video, but I found one. It's super annoying, but I'm going to skip through it to the pieces I like, and you guys can watch that. Okay. All right. So let me show you on Schoology where you can find what I'm going to be talking about if you want to follow along. I'm going to add some, just kidding. I'm going to add some more stuff to the Schoology folder today, but I'll show you what I have in there right now. Okay. So if you go to Schoology, share my screen. All right, if you go to Schoology and you go to the classroom, remember the classroom is just to save you some clicks, okay? And if you go to today's lesson, it's going to take you to the folder we're in. I'm going to put some more stuff in here, some more notes, but here is the video that we just watched on how to separate the seemingly inseparable, so separation techniques. And then here is a list of the different ways we can separate mixtures. So if you notice on the side right here, it says mixtures are not chemically combined, okay? What is the only thing that's chemically combined that we talked about? Starts with a C.
Compounds.
Compound.
Very nice. Those are the only things that's chemically combined because the element is just the element, and then compounds are chemically combined, and then mixtures are physically combined. So they can be separated physically, okay? All right, so we're gonna talk about a couple of these: magnetism, filtration, screening, evaporation, distillation. We probably won't talk about crystallization that much, but just think about like what pop rocks is like. That's basically what crystallization is. Sublimation, chromatography, we kind of already talked about that, and centrifuge. Now this is here, I have this in another folder with some extra notes, and I'm gonna put the extra notes in Schoology this evening, but I'm gonna go to that folder to kind of talk about stuff. So give me 1 second, I'm just gonna switch my screen again here so that we can talk about that. All right, the first thing I want to do before I even switch screens is to ask you, what did I do with them? What is the things that I lost? Okay, let me go find more. I got more. Tell me what, I just came in. Let's see who that is. That is, somebody just came in. God. Oh, it's John. All right, so, oh, here it is, it's right here. All right, so I have these little pieces of, they're like little washers. Let me see if you can see them. Can you guys see that? Like little washers in my hand? Okay.
Yeah.
All right, and then I have these big circle things. It's a science term, big circle things, okay? Any guesses what this is? No guesses.
Magnet?
Very nice. They are magnets, okay? So our first separation technique is actually magnetism, all right? So I can take these and there we go. All right, so this is our first separation technique. Pretty simple. It separates things that are magnetic. What do you know that are usually, what's usually magnetic? What type of things?
Fridge?
Yes, your fridge is magnetic. It usually has a magnetic side. And what's it made out of though?
Metal.
Yes. So metals, not all metals, but some metals are magnetic. So like iron is really magnetic. Iron and like nickel, okay? So not all metals are magnetic. So like gold, if you ever try to put a magnet next to like a can of Coke, nothing happens because aluminum is not magnetic, okay? So let me share my screen. We can talk about magnetism for a second, okay? Making sure you see what I see. There we go. So one of our first separation techniques is magnetism, okay? And if you look here, let me get my mouse here, okay? Like on this picture here, they have like, there's some sand and there's some iron filings in there. So you can find iron filings a lot like in a, or like buckshot. Anybody like hunt or shoot or anything like that? Those usually are magnetic as well, okay? So with those, if you wanted to separate that stuff out, you can just take a magnet over it, okay? And it's gonna pick up the iron filings and leave whatever you don't need. So on that one, I don't know if you need to write any notes on that. You can say usually metals, but not all metals, but usually, I think most of us know what magnets are. So we can use that as a separation technique. Think about, imagine, you ever seen like those movies and the people are on the beach and they're searching for coins, but sometimes it picks it up, okay? Or, a junkyard, right? Those giant, I don't even know what you call those machines, with the arms and they pick up like all the magnetic stuff, like car pieces and put them somewhere else and leave all the other trash there. So magnetism, right? Filtration, okay, so now we're on number 2, filtration. I'm gonna try to write, okay, filtration right here uses a porous barrier, which is a fancy word for paper with little bitty holes, okay? Paper with itty bitty holes in it, okay, to separate solids and liquids. This is a really important thing. I would write this down because it's going to be on the test because I thought of it second block and thought this was a good question, okay? It will separate only heterogeneous mixtures, which is a colloid or a suspension. It will not separate solutions. Why do you think it won't separate solutions?
Because solutions are the same thing and there's nothing to separate.
Well, there's stuff in there, but what do you know about the stuff inside of a solution?
The particles are too small.
They're too small. So just think about that. If a filter is a paper with itty bitty holes, then the solution, the stuff in the solution must be itty bitty. It's super, super tiny. So for example, let me tell you about my favorite filtration. I do it every day, okay? This is my favorite. I come in every morning. Miss Sandifer's in here with me, and Miss Baird, if you've ever had her. And I go straight to the back, and I take this piece of paper, and I put in this machine.
Is it a coffee filter?
Yes, it is a coffee filter. It's filled with a whole bunch of coffee grounds because I need my coffee for the day. And then when I take my water and I put it through, all right, luckily, when I get my cup and put it under here, thank goodness, because that would be really gross, it only comes out with the brown water, i.e. my coffee, and there's no coffee grounds in there because that would be disgusting because I like to drink my coffee, not eat it, okay? So yes, this is my favorite filtration, okay? And if you look at the paper for a coffee filter, you can't even see the holes. They're super, super tiny. They're there, but they're super, super tiny. You can't even see them. You can kind of see that you can see through it, okay? Here's another coffee filter. So if I had some type of solid, you can kind of see through it a little bit. The holes are super tiny, all right? So if I were to put a solid and a liquid in there, the solid would stay inside of the paper because the solid is too big to go through the holes, but the liquid will, okay? So think about if you also had, for example, all right, think about if you had some muddy water, right? So here's another example. All right, so here's a mixture of sand and water, all right? I put this funnel right here, put a piece of, so right here, this little thin white line making a V is supposed to be the filter paper, and it's thin because it is thin. All right, well, once I pour all that stuff, so I'm gonna take this beaker, pour it into the filter paper, all of the bigger particles are going to stay up here and the solution is going, or the liquid is going to go through. Now, let's pretend that this was a mixture of water, sand, and salt. Sand, water, and salt. Where do you think the salt would be? Would it be in the top with the brown stuff or in the bottom with the water?
The water.
It would be because salt water is a solution. Those particles are super, super tiny. So I would have to do something else, okay? I would have to do something else if I had salt in here, okay? So if I also had salt, the salt would be down here with the water, okay? And I would have to do something else. I could separate the salt from that water, but I couldn't use filter paper to do that, okay? All right, so that is filtration. All right, let's see what we got next. So so far we have covered magnetism, and I'm moving my mouse, but it's not going anywhere. We covered magnetism and filtration. Screening, evaporation, distillation. Okay, screening, evaporation, distillation. Let's talk about evaporation and distillation. Okay, we were talking about the salt being in this solution right here, okay? I could very well take this liquid, all right, put in a cup, oops. I have a cup, I've got my salt water in here. What happens if I just leave it here for a couple of days, or let's say a couple of months? What eventually happens to that water?
It evaporates.
It will evaporate. It's going to turn into a gas, okay? It's going to turn into a gas, all right? And then if I do that, guess what's going to be left behind?
Salt.
Salt is going to be left behind, okay? So I could do it two ways. I could evaporate, I could just let it sit there and evaporate, all right? And then remember when we talked about phase changes, we said you could do evaporation, or what was the other one that was kind of similar? We do it in our kitchen, on the stove.
Boiling.
Boiling, yes, boiling. So I could also boil that, okay? And that is what distillation is. So let's talk about that, okay? All right, so distillation, I probably should not be saying this, but however, it's a big industry, and I'm going to tell you some of the companies that use it. And if you know what these companies are, fantastic. And at the same time, why do you know what they are? I'm just kidding, okay? So here are some of the companies that use distillation, all right? Anheuser-Busch, Miller Coors, Jack Daniels, who else? Smirnoff, yes. There's Crown Royal. Anybody know what I'm talking about? Anybody gonna admit they know what I'm talking about?
Liquor.
What'd you say, Whitney?
Liquor.
Yes, and you said that way too happy. You said liquor. I heard that, Whitney. I heard that, okay? Yes, it is liquor and or alcohol in general, okay? So it could be wine, it could be liquor, it could be beer, okay? But all of those companies use distillation, okay? Distillation. I'm going to show you a quick video right now, but go ahead and make a note. You don't have to write this fractional part. Let's make a note that distillation is based on different boiling points, okay? So it is best for separating two or more liquids, okay? So make a note of that. I'm gonna get ready to show you this other video while you're making a note of that, okay? Distillation is based on boiling points, and it is for two or more liquids, okay? I'm going to get ready to show you this other video. Fantastic. All right, you guys got that down? Okay, I'm gonna assume you guys got it down. So we're only gonna watch about 2 minutes of this video. All right, new share. Here we are. All right, making sure you can see it. Yes, you can. Here we go.
Professor Dave here. Let's do some distilling.
He knows a lot about the science stuff. Professor Dave explains.
I need a video like this.
We've learned a few different techniques for separating the components of a mixture. Extraction utilizes differences in solubility. Chromatography utilizes differences in polarity. There is another technique that utilizes differences in boiling points, and it's called distillation. Let's go ahead and check out a distillation apparatus now, along with some instructions and tips for how to do this properly. The idea behind distillation is quite simple to understand. Given a mixture of two miscible liquids, if they have very disparate boiling points, we should be able to heat up the mixture to a temperature that is above the boiling point of one compound, but below the boiling point of the other. This will cause the one with the lower boiling point to go into the gas phase, such that we can collect the vapor and condense it elsewhere, while the one with the higher boiling point will just stay right where it is. And in fact, the technique is pretty much as simple as that, but there are a lot of things to discuss regarding the setup. So let's see what this looks like. Here we can see a distilling flask, usually a round bottom flask. And our mixture will go in here, along with a couple of boiling chips. This will sit above the heat source, be it a hot plate, Bunsen burner, or whatever we are using. We bring the mixture to a gentle boil and vapor is produced. This vapor will rise into the side arm and a thermometer will sit here, measuring the temperature of vapor right as it approaches this horizontal section. The vapor continues into the condenser. This has a central hollow section where the vapor will pass, surrounded by another section where cold water will enter on one side and then exit from the other. This will be constantly running and against the direction of the vapor. This cold water will cause the temperature inside the condenser to drop. So when the vapor enters this section, it will condense back into a liquid. This liquid is called the distillate, and we will collect it in a receiving flask. And just like that, separation is achieved.
All right, so I'm going to show you actually a condenser, but again, you could have multiple liquids in this flask that have different boiling points. So maybe one has a boiling point of 100 degrees Celsius, maybe one's 150, and maybe one is 200, okay? So you can actually have apparatuses like this where there's multiple of these cooling tubes that are coming out. So maybe there's one stacked here, and maybe there's one stacked on top of that, okay? So as the first one that reaches its boiling point is gonna come off here, and the second one that reaches its boiling point will come off here. And we can collect it because we know that if you cool off a gas, it turns back into a liquid, okay? So here is, I've dropped that 4 times. Okay, here is, for example, a condenser tube. So if I had this connected, I would have the cold water going in here, and the cold water is just kind of like on the outside of this tool, so not in the like squiggly part. So the gas that would get collected from my boiling flask down here would come in here as a gas, but then as soon as it went through here, it would cool off because there's cold water running through the outside, and it would drip out this end, and that's how it would catch it. Okay, so that's really what they do in the alcohol industry, because for some people, for some reason, people don't like water in their alcohol. Anyway, moving forward, okay, so that is that. So distillation is based off of boiling points, okay? The one that we skipped over was screening, okay? That one's super easy. I think about the gold rush, so it's basically sifting. We do it in the kitchen, we do it with, we're, I guess, searching for gold. If you do that on a regular basis, I don't know. But it's exactly what it sounds like. It's something that has holes in it. You shake it. Big stuff stays on top. Little stuff falls through. The end. That's what screening is, okay? So you think about the gold rushing people, and they're out there and they're searching for gold. They want those big chunks. And remember, this can be bigger or smaller, or maybe you're, I don't know, cooking something and you have to shake the flour off. So if you had chicken with flour on it, the extra flour would fall through. I don't know. You can use it, okay? That's all that matters. Okay. Let's go back, see which ones we're missing. We're almost done. Okay. So we talked about the distillation, and we have talked about the, you can call it sifting or you can call it screening, whichever. So far we've covered magnetism, filtration, which is number 2, screening, which is number 3, 4 and 5, evaporation and distillation. We're gonna skip 6. 7 would just be if you had 2 gases and one of them turns, I'm sorry, if you had 2 solids and one of them sublimes, like we talked about the dry ice, how it goes straight from a solid to a gas. So sublimation. This is kind of cool if you think about it. Evaporation and sublimation are separation techniques, but what else are they? What's the other thing we studied? Starts with a P, 2 words. There was sublimation, evaporation, freezing, melting.
Precipitation.
What is it?
Precipitation.
Yeah, but we talked about melting and freezing and evaporation and sublimation.
Phase change.
Phase changes, yes. So sometimes we can use phase changes, evaporation and sublimation, to also separate things out, okay? All right, chromatography, we kind of talked about that just a little bit when Whitney mentioned the crime scene one was kind of cool, and that's stuff moving at a certain speed, but you don't need to focus on that one. The last one I want to show you is centrifuge. So this video is really wacky. I'm gonna have to skip around on it, but I want you to kind of see basically what's happening. There's basically this machine and it spins stuff really, really, really fast, really fast. So I'm going to show you this one last video, okay? And then we will be done for the day. See, you didn't have to take a whole lot of notes. It was easy learning today, hopefully. Hopefully you think it was easy learning. Nothing too hard. All right, let me find this wacky video.
Topic.
Okay. All right, I'm gonna skip around because it is kind of kooky. Did I do my new share? New share. There we go. All right, here we go. I'm gonna skip around a little bit. This will be our last one.
Centrifugation. How is the principle of centrifugation helpful in blood banks? Don't know the answer? No worries. We shall find the solution.
All right. They spent 30 seconds with him chasing some jelly. I don't know what's up with that, but that's what he does. All right, here we go.
Do you know that jelly is a colloidal solution? A colloidal solution is a solution whose particles neither dissolve nor settle down. Another example of a colloidal solution is blood. Blood consists of various components like red blood cells, white blood cells, platelets, plasma, etc., which neither dissolve nor settle down. Usually in blood banks, when a blood sample needs to be tested, its components have to be separated. So, how can we separate those components?
And this is why we skip a little bit, because it's a little weird. Don't ask me what he was talking about. I don't know. He's getting chased by some blob and he uses an umbrella. I don't know.
What do you think? Can we use a filtration technique to separate various components of blood? No. Filtration is not useful because the size of the components of blood is so small that they can easily pass through a filter paper.
Telling you, this little thingy's weird. All right, so let's go to
Similar to this merry-go-round, a machine called centrifuge is used in blood banks to separate blood components. In the centrifuge machine, a test tube filled with a blood sample is rotated at a constant high speed. This process is called centrifugation. Centrifugation is based on centripetal acceleration. Due to centripetal acceleration, the heavier components, that is, the red blood cells, move outwards. The white blood cells and platelets, which are lighter than red blood cells, form the middle layer, and plasma, being the lightest, moves towards the center. In this way, components of blood get separated by the principle of centrifugation.
I don't know what's going on with this thing. All right, so that is centrifuge. And there it really is, there's some videos of like an actual centrifuge, but it spins, when I say fast, it spins really, really fast. I'm talking about like thousands of revolutions, which is revolutions like how many, like going around once, thousands of revolutions per minute, okay, thousands. So it spins really fast and it can separate out your blood. And centrifuge can be used for a couple of different things. So it could separate milk. It could separate if you wanted to, for whatever reason, or whatever else you need to separate. All right. So we got 5 minutes left. This is what I want to do to finish up. As we prepare for our quiz slash test, let's talk about, let's just make a quick list of all the stuff we have talked about this unit that you think will be on the test or quiz. All right, so anybody can start. Tell me something we talked about, or I can call on people, whatever you would like.
Two mixtures.
Mixtures, very nice. All right, so we've talked about mixtures, the two types of mixtures. Let's find another color here. So we've talked about the two mixtures. All right, specifically homogeneous and hetero. Hetero. All right, that's one thing. What else have we talked about? So for the left,
Elements.
say again.
Compounds and elements.
Very nice. Compounds and elements. All right. I want Joe, Isaiah, Cameron, and Dominic to give me something. So whoever answers first, you're more likely to not have to think it's hard, just a thought.
Ask it one more time.
Yes, what is something we've talked about in this unit over matter?
That it can't, like you can't make it.
Yes, you can't make it. And what else is something that we like maybe spent a day on? Tell me something you know about matter.
Well, it can't be destroyed, right?
Cannot be destroyed. So law of conservation, I'll take that. Law of conservation of matter. Nice job, Joe. Dominic, Cameron, Isaiah, got something?
There's many ways to change a matter's state.
Very nice. So that's kind of two things. So we can do states of matter. Sounds good. States of matter. You kind of led into something else. Maybe you help somebody else. Cameron or Isaiah, you said about changing states of matter. What are those called? Cameron, Isaiah, are you there?
Yeah, I'm here.
Okay. What do you call it when you're changing in between states of matter? Like we talked about evaporation and melting and freezing, sublimation. What are those called? Starts with a P. Somebody help them out.
Phase changes.
Phase changes. Very nice. Phase changes. All right, what else have we talked about? Jamie, you got something for me?
Chemical and physical properties.
Yes, somebody, thank you. Yes, physical and chemical properties. That's a big hint for something else that somebody could play off of. You said physical and chemical properties. Anybody got something else?
Physical and chemical changes.
Physical and chemical changes, yes. I'm gonna hope that you guys are just not wanting to talk today and don't actually know this stuff. All right, and then somebody could have said this one since I put the page back up. Yes, separation techniques. All right, study guide should go up sometime to green today and tomorrow. And then we're gonna quiz on Monday. So if you didn't know this stuff, I hope you know it by Monday. Yes? Fantastic. Yes, Ms. Payton, we're gonna know it because we don't want to fail. All right, woo-hoo! Fantastic. See you guys Monday. Goodbye. Later.
You said there's gonna be a study guide.
I'm gonna make a study guide. Yes, I'm gonna make a study guide, but it's basically all that stuff we just wrote down. So if you know your phase changes, your states of matter, physical chemical properties. What else did we say? The newest thing is just the stuff we did today, separation techniques. Everything else I feel like should be okay. I think people would struggle with maybe compound element. Maybe like how we were doing. If you did good yesterday when we were doing like, is this homogeneous, heterogeneous, compound, or element, you'll be fine on that too. So, any other questions? That's all I got for you guys today. Sorry we did.